we are going to do our review for atoms and molecules. So as you're listening to this, you'll want to listen for the 2 code words that you'll want to report back to me in order to earn your prize. But don't tell other people. So listen for the 2 code words. So the first thing we're going to do is define atoms, elements, and molecules. So an atom is the smallest part of matter. So we can't break it down anymore and still make something if we were to break it down. So an atom is the smallest thing that can still make up something else. It makes up the elements, it makes up the molecules, and then everything is made up of molecules. So our atoms are that building block for matter. So we could have an oxygen atom. So it's one single atom, right? I can't break it down anymore. I could have a carbon atom. I could have a hydrogen atom. So they have the properties, but they can't be broken down anymore. If I cut this atom apart anymore, it would no longer be hydrogen and it couldn't make something on its own. So an atom is one single thing. So an element is, again, these same things. So I'm going to use this carbon as our example here. And I'm going to put another atom with it. Another one. I'm going to actually move this guy down here. I've got another one here. So an element is made up of one type of atom, just the same type of atom over and over again. So here I have a group of the same type of atom. There's all carbon. So that is an element. These are all things we would find on the periodic table of elements. If I took this one away, they're still the same. I still have the element of carbon. If I take this one away, I still have the element of carbon. They're all the same. If I take this away, I still have the element carbon. There's nothing making it different. So an element can be anything from one atom to millions of atoms that are all the same. As long as they are the same type of atom, we call that an element. But as soon as I add a different type of element to it, now it's no longer an element. Now I have some carbon atoms and an iron atom. So if I remove that, then it's pure and clean again, and it's an element. So an element just has to be the same type of atom. So even if it's just one, this is an element all by itself. But usually when it's one, we just call it an atom. So then we also have our molecules. So the difference between elements and molecules is that our molecules have to be bonded together. So it could be made up of the same thing. I could have 2 oxygens and they bond together and touch, and now it's made that chemical bond and it's a molecule. So it is the same, but so it's an elemental molecule, but it's still a molecule because it was bonded together. I can add in another type of atom, so they can be different as well. And it's still a molecule because they're bonded together, but now it's a compound molecule because they're not the same. So an atom is the building block. It's a single atom, a single type. An element, or all the different types of atoms that you can have, and they have to be pure. And then our molecules are when we take those atoms and we bond them together to create chemical formulas and those recipes for what we need. Okay, your first code word is spicy. First code word is spicy. Okay, if we are wanting to identify that chemical formula, so this is a chemical formula, that recipe that tells us what that molecule is made up of. So when I'm looking for the elements, what is it made up of? I look for the capital letters. Every time we have a capital letter, that's telling us that is a new element. So we can break it up. So here I can see Na. The A has to connect to the N, I see a capital C and an Fe. So this molecule is made up of 3 different elements. Then we also can count how many atoms are in this molecule. And we do that with the numbers. So I have 3 NAs, so 3 sodiums. There's nothing after this C. So that means I have 1 of those. So there's nothing there. You still have 1 of them in your formula. And then I have 2 Fe's. So 3 plus 1 plus 2 is 6 total atoms. So 3 elements, Na, C, Fe, and 6 atoms, 3 and 1 and 2. If I was drawing that, I would need 3 NAs, and I need to bond them together to make my molecule. So here is Na, 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 and then I need 1 C, 1 carbon, and 2 Fe's. So we can just connect them and make sure I have all of my different pieces. So if I'm going backwards, I can do the same thing. So here's 1 element, Na, here's my C, here's my Fe, so there's my 3 elements, and it's made up of 1, 2, 3, 4, 5, 6 atoms. So you can always check yourself either way, from the formula to the model to your counting each time. So this here, we have this chemical formula NH3. So if I was describing this, I want to break it down and go piece by piece to look at it. So I can see the N, I have 1 of those. So this is made of 1 nitrogen, and then I can see I have 1, 2, 3 hydrogen and 3 hydrogen atoms. So atom, 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 atoms. That's made up of 4 total atoms. So this is made of 1 nitrogen and 3 hydrogen atoms to make a single molecule. So even though there's 4 things, they bonded together, and now this is making 1 single molecule. So I can have more of those that would bond on, but as this is right here, it's just 1 because it's all now connected into that group. It's a team now, it's 1 team. So if I want to compare these molecules, I want to go piece by piece, atom by atom, element by element. So if I'm looking here, I can see I have C and I have O2. I have H2 and I have an O. So I'm just going to start thinking out loud here. I can see I have 1, 2, 3 atoms. So I have 3 atoms and 2 elements, the C and the O. This one also has 1, 2, 3 atoms and 1, 2 elements. So if I'm just looking at the numbers, they sound very similar. So I might even start my paragraph with that. These molecules both have 3 atoms and 2 elements. However, they're not the same. CO2 has carbon and H2O has hydrogen. So, right, this one has carbon and this one has hydrogen. So that's something that's an element that is different about them. They do both have oxygen. So I can see they both have an O, but CO2, oops, has more oxygen than the water molecule. So I can just go through each part, compare it. So I compared how many atoms they have, how many elements they have, which they were the same. And then I broke it down. I noticed they both have an O, but not exactly the same amount. But right, CO2 has more. I could even add has one more oxygen atom than the water molecule. So that kind of even bumps it up to that next level there. So just adding those few extra words. And then I compared that this one had carbon and this one had hydrogen. So there's some things that were the same, some things that were different. Go piece by piece. Hey, all right, your second word is Cheetos. So tell me your 2 code words and I will get you your prize.